The availability of energy is still a big problem for human life. Various efforts have been made to meet this energy demand. One of the efforts that we can make is to produce alternative energy sources from natural materials which are abundant and renewable. On the other hand, due to rapid population growth, uncontrolled plastic waste has been generated. In Indonesia, according to Indonesian domestic waste statistics, types of plastic waste are in second place, with 5.4 million tons per year or 15% of total waste production. Not only inorganic waste but also organic waste has yet to be utilized effectively. Particularly in Central Java, East Java, and Madura, there are many Siwalan plantations. The Siwalan fiber found in Siwalan trees is used sparingly and is disposed of as waste. Introducing Azzuline, Azzurium-Gasoline, is a product of blending pyrolyzed naphtha and bioethanol from Siwalan waste, which can produce gasoline as an alternative fuel. This research aims to produce a renewable and environmentally friendly fuel.
Plastic waste is collected and soaked with 1% disinfectant for an hour, then dried in the sun for 24 hours. After that, the PET and PP plastic are cut into small pieces. The PET enters reactor 1 and a thermal cracking process occurs at a temperature of 400 degrees and a pressure of 1 atm. Thermal cracking breaks a large hydrocarbon molecules with long chains of carbon atoms into smaller hydrocarbon molecules by utilizing heat. Furthermore, the products resulting from the cracking will enter reactor 2, and a hydroprocessing or hydrocracking process will occur with the help of hydrogens injections and a hollow-side nanotubes catalyst. The reactor output also undergoes a reforming process with the help of an R34 catalyst to increase the octane value of the product. The resulting product is in the form of a gas phase, and when the gas phase is then cooled using a condenser so that the final product produced is in the form of liquid phase naphtha. The Siwalan waste is chopped to a specific size and then dried using an oven to obtain a constant weight. Dried Siwalan waste was put into sodium hydroxide solutions with a concentrations of 1 normality and heat for 30 minutes to reduce the lignin content. Then, 3% of sulfuric acid was added and heated at 120 degrees for 30 minutes to form glucose. The glucose produced is then fermented for 5 days using baker's yeast or Saccharomyces to form ethanol. Then it is distilled to purify ethanol. Blending is mixing 2 or more products to get the desired result. In this case, blending is carried out using naphtha products resulting from the pyrolysis of PET and PP plastic waste and bioethanol from Siwalan waste. The blending is intended to produce biofuel E30 with a composition of 70% naphtha and 30% bioethanol. The blending process was carried out at 16 degrees with 100 rpm stirring. After blending, the resulting product must be tasted to determine specifications to comply with fuel requirements. Some of the tests carried out are based on the table below. octane number, density, and rate paper pressure. The blending process occurs between the Naphtha product from pyrolysis and the bioethanol product from the Siwalan waste. Mixing these two products is to obtain optimal biofuel specifications ready to use as alternative fuels. Based on the test results, it can be concluded that the product blending naphtha resulting from pyrolysis and bioethanol from Siwalan fields can be used as an alternative fuel. In addition, the resulting emissions are also lower than the emissions of fossil fuel products.
The reactor that is used has a maximum capacity of 5 kilograms. In this case, it is assumed that there will be 5 kilograms of feed. The total cost of Azzuline production can be seen in the following table below. The cost-profit calculation of the Azzuline product can be seen as below. If the product sells for $3.8 per liter in one day, it could get a profit of $0.54. The Azzuline product has the advantage of reducing plastic waste and Siwalan waste, especially in Indonesia. Environmentally friendly fuel, long-term, can meet energy consumption needs, and finally, the raw materials are cheap and easy to find.